Hello everyone. Welcome back to the DSA for Beginner series. In our previous videos, we saw tree traversals. So, as you remember, we have depth first search and breadth first search. In depth first search, we saw uh, three different types of DFS. One is in order, reorder, post order. So all of them we have notations here: left, root, right, and root, left, right. Pre is basically root will come first, that is pre. You can remember this. And post is like root will come at the end. So in order is root will come in between the right and left node. So that is the easiest way to remember that. If you have not watched the video, please go and watch the depth first search traversal videos in my channel. So next, so let's see uh, a, a technique called breadth first search. What is breadth first search? So in our depth first search, what used to happen? So in, let's say this was the tree. So if you see here, depth first search was basically the traversal used to go to the depth of the tree. So here also it used to go till the depth of the tree. So that is why we used to call this as a depth first search. So in this breadth first search, what we do, we go through breadth of the tree. Basically, breadth is something like the traversal will happen like this through the breadth of the tree. So in the first level, basically breadth first search is also known as level order traversal. Where at each level, what all nodes are there, we need to traverse those. Okay, for example, how breadth first search will look like. So let's take this 4, 5, 6, and 7. So if we do level order traversal for this, basically breadth first search, how the tree will be printed, the traversal will be printed is 1, 2, first level it was printed, then second level we have 2 and 3, then the third level 4, 5, 6, 7. This is how the breadth first search will look like. So how do we do this? Hmm. So in depth first search, we used a concept called recursion. So how recursion happens is it goes to node and then it goes to the depth of each node. Basically, recursions will work there. But in case of breadth first search, how can we do that? So as we saw, we have an option to do that in queue. Basically, queue is nothing but first in, first out. First in, first out concept. I have already explained this in my previous tutorials. So basically, if one comes first in the queue, so that will go out first. 2, go out first. 3, go out first. 4, go out first. Same thing. So we can make use of this concept and then we can do this level order traversal. Let's see a dry run, how we can do this. Okay, so for example, we have a 3, 2, 3, 4, 5, 6, and 7. So what we need to do is we need to insert the first node. Basically, you will have one inserted. So let's take it like this. Okay. So one got inserted here. So the let's take this is the queue front and this is the back. So from here the first item got inserted. Then we go to this node and see if we have a left node and a right node. And if there is left and right, then add this also. So both left and right got added. Then this is we have already traversed. So this we can remove from the queue. Basically, queue.pull we can do to pop out the first element. Okay. Then take the next element in the queue, which is 2. Here also we can see if there is a left element, add that. Again, if there is a right element, add that. So meanwhile, once you add that, right, you can add it into a list for the traversal, or if you are going to directly print it, then just print the element. Same goes with the first element. First element got inserted, then just print it. So this is the traversal. So if you are going to print it, first got printed here, then second, we visited the second node, then printed, then we added 4 and 5, and then this got removed from the queue. Then what is the next element? We have 3. So again, we print the third element. Then what we have left? Yes, we have left. Then we have right. Then we have right. Add it into the queue. Then remove this from the queue. What is we have? What else next? Next entry in the queue we have 4. 4 we have added into the traversal. Do we have any left or right? No left. No left. So none of the items will be added to the queue. So 4 is removed. Then again, next, what is the element? 5. That also added to the traversal. No element, no element. So no element added to the queue. Next, 6 added to the traversal. No elements, no elements, no element into the queue. So we go until the last element. We do this until the queue is empty. Queue is okay. So if queue is empty means that we have uh, traversed all the nodes in the tree. Okay, so let's take another example just to be very clear. Okay, 1, 2. So let's take only one element on the right, 6, 7, 5, 8, and only 9. So in this case, what happens? So first level, first queue, it got added. So, so this is the queue front. This is the traversal. Okay, first element got added. Then we take the first element out, then add it to the traversal list or a traversal we just printed. Then check if left and right are there. We have left and then right. So add it to the queue, both left and right. Then this got removed. Then next element, we have 2, take it out of the queue, add it to the traversal, and then check if left and right are there. We have only right element, so add it to the queue. Okay. Then third element. So take out from the queue, add it to the traversal list, then check if there is any left and right. So we have 5, 8. So we have 2 elements left and right. So add it into the queue. Next, we have 4 in the queue. Take it out of the queue, add it to the traversal. Then check. Do we have a left? Yes, we have a left. Do we have right? Yes, we have right. Add it to the queue. Done. Next. Next element from the queue is 5. Remove it out of the queue, add it to the traversal, added it to the traversal, then check if there is any left and right. So no left, no right. So nothing is added into the queue. Then what is the next element? We have 8 removed from the queue, add it to the list, then check if there is any item left in the left or right. So there is no left item. We have right element. So add it to the queue. Okay. Then remove the next. What is the next element in the queue? 6. Remove it from the queue, add it to the traversal, then check if there is any left, right, no element left and right, so nothing will be added into the queue. Then pop out Next element is 7. Remove it from the queue. Add it to the traversal. No left, no right. Then the last element 9. Remove it from the queue and add it to the traversal. There is no right and left. So this is how the level order traversal happens. Let's see a simple pseudocode for this. Basically, we need a queue of integer, queue equal to new linked list. So basically, we can use linked list or a array for queue. Okay. So we add the first element root queue dot. So queue dot offer of root. Okay. Then while queue dot is empty, then we add it into the list node basically queue dot poll. Okay. Then check for we need to check how many are there, right? I equal to 0. I okay, 1 second. Okay, so what we are doing here? So basically, we are just taking the size of the queue. That is why we are doing. So for each level, how many nodes are there that we can check, right? So we have to iterate toward through the queue for those many number of nodes in that particular level. So if you see here, right? So in this level, we had two nodes. So for these two nodes, we have to iterate and add it to the list. Same goes in this level. So we have to iterate it for 3 entries and then add it to the list. So same we are doing it here. So we add it to the current level of list and then we'll check if current dot left is present, then add it equal to null, then add it q dot offer current dot right, then close this and then so we can declare something called a final answer list of integers here. So this will be the answer your list. So here for each level after traversing, so this is basically we are traversing in one level. So we can add it dot add of this current level list. Okay. So this will do until queue is empty. Okay, I hope it is clear. So let's solve this in our LeetCode. Okay, as we can see here, so this is our code for our level order traversal. So we have taken a queue, so offered the first element, then iterate through the queue elements, and then add if left is present and right is present. Then again, we'll keep iterating until the queue is empty. So let's see. I hope it compiles fine. Yes, it's working fine. Okay, by this, we have covered most of the traversal techniques, DFS, BFS, and level order traversals. Will maybe in our future tutorials, we can see some questions on traversal uh, techniques or something like that. Okay. Uh, I think let's end this session here. Thanks for watching. Please subscribe. Happy coding.